Hello everyone. Today I am going to explain you how to read a Lineweaver-Burke plot. You can see this graph in which n line represents the normal graph. First and second we have to identify. Okay. So by default in this graph we have to learn that on y-axis we have 1 upon v and on x-axis we have 1 upon s. S is the substrate concentration and v is the velocity of the enzyme action. So to understand this we need to frame equations in basic, like in 11th and 12th we have read that every graph has an equation. Okay, so if we make an equation for n line, we can make that yn is equal to mn xn plus cn. Now let me explain you. Y is the y-axis of n, which is equals to m, that is slope of n, means this angle, and x is the distance which has been covered by n line on y-axis, and c is the intercept means this length. So similarly we'll make equation for first and second line. So y first is equals to m first x first plus c first. Y second equals to m second x second plus c second. Okay, we can see that c of n, let me show you this, c of n and c of second line, they are same. So means this y2 and yn are constant, not constant like their intercept is constant, they are intersecting at a common point on y-axis. So 1 by v is constant. Let me write 1 by v of normal and second line is constant. So velocity is constant. We know that this v is velocity. If v is constant, then 1 by v is also constant. It is nothing like that. So we came across that if velocity is constant, then it is a competitive inhibitor. We know that this is, if suppose this is enzyme, this is a substrate binding site. So in competitive inhibitor, a substance which is similar looking to the original substrate, suppose this is substrate and this is another substance X, say, they both look similar, so they occupy this space which is known as the substrate binding site of the enzyme. So the graph goes like this. If here is the K and here is V, sorry, here is substrate, then the graph goes like this. Okay, so in competitive inhibitor graph, the velocity is constant and K max changes. So that's how we came to know. So if I summarize this, then it is the second line represents constant velocity graph, then this graph of second line shows competitive inhibition, and graph of first line shows non-competitive inhibition. Okay, because first line has a common 1 by S intersection. That means substrate concentration is common. If substrate concentration is common, then velocity will decrease and Km will remain constant. So that's how it goes.